Greetings, this is Artie from Artifact Electronics. So I recently picked up some vintage computer stuff, and as part of that haul I got these two Atari 1050 floppy drives. Condition unknown, they came with no power supplies, couldn't be tested on site in the guy's garage, so I got them pretty cheaply. Thought we'd give them a shot. So first we have this guy, which is cosmetically in better condition than the other one, except it's got this little thing having separated and the trim strip. And once those get bent, they're really difficult to put back nicely because the aluminum bends, and no matter how hard you glue these down, they never become smooth again. But I think that's the least of our worries right now. Let's test it and see what's happening inside. Now the other one, as you can see, has lots of ugly marks on it. But I couldn't help myself. I was able to make a clean spot over here. So this stuff actually comes off with like simple green or Windex or something like that. But yeah, it's pretty dirty. Now, one initial test we can run on these is when you turn on the drives, the power light's supposed to come on, and the drive light also. The drive's supposed to spin. So this one, I put one of my own power supplies into it. It's got one of these power breaks that outputs, I think, 9 volts AC. So if we turn this one on, so we could definitely hear, the power light's on and we could hear the drive seek. So that's a good sign because that's a basic sign of life on the drive. It still doesn't mean that it's going to work, but at least it does something. Now on this one, let's plug in power to it. And I tried this already, and it's not very cooperative. I think the power plug might be bent on this. And I can't do it with one hand, so be right back. I definitely did need two hands on this one because that plug just didn't want to go in. It looks like things are a little bit bent inside. So that's one of the first things we're going to have to attend to, but let's do the Powerup test on this. And on this one, the drive does nothing. No seek, no anything. So I think it's probably not a good idea to plug that one in. But since this one showed signs of life, let's hook them up to an Atari. These were made for the Atari 800 series computers, and they were basically the successors to the 810 drives. They have something, the 810 drives could hold 100K, and these have something called the enhanced density mode, which gives them, I think, an extra 20 or 30K of storage. I'm not exactly sure what that means right now. I'd have to read up on it, but they have a somewhat larger capacity than the original drives. So yeah, let's see if any of these, well, not any of these. As I said, this guy's going to have to be taken apart first, but I think we can test this guy with an Atari setup. I set up an 800XL, hooked it up to the drive with the serial cable, and we got a Panasonic monitor. I think it's in its former life it was like a security camera monitor or a broadcast monitoring monitor. I don't know, but these are pretty good for video games. Fully analog, of course. So I've mounted a disc in here. So let's give it the beans and see what it does. Nothing. that? Too many nothings. Oh, the disk drive isn't turned on. So let's see if he still comes to life. Oh, the power switch is in front. They were kind of inconsistent, where the power switches were at different locations on all of these guys, but so that still seems to acknowledge that there's a disk in there. It actually sits there for a while and then times out. So now so that drive seems to work. Let's try to load something. We'll try Popeye. Amazing how fast these drives are. Okay, so it didn't boot up, but one thing I remember is these were images made from cartridges for the Atari 800. And the 800 XL, even though they say it's fully compatible, it is not. There are some differences, and this sometimes happens. I don't know whether it has 64K rather than the 48K that the 800 does. So one thing that I remember doing is, if you press the option key over here, while booting it, it comes up in Atari 800 mode. So it reconfigures itself, and let's see if that works. So I turn it off. And I got to briefly put the camera down because I can't span with a single hand the power switch to the option key. So pardon me. All right. Okay, and this time I'm just going to do Ms. Pack. Yep. Put it in compatibility mode and it works. Does the game run? Start button maybe? Yep, seems to work. And so on and so forth. So this drive is good. I'm going to clean it up. Probably try it out with a few other games, but it looks like this one is a go. Here's a second drive. Took out the screws holding the case halves together. And one of the screws was missing, or is missing. So somebody's been in here before. Also another 2 screws that hold the bezel in place. So let's turn her over and see what's inside. Here's what the inside looks like. Obviously the drive sitting on top of the PCB. It is a Tandem TM50 drive. And the interesting thing here is normally when you're looking at these drives, they have the drive electronics as a board mounted on top of the drive here with the drive electronics. Not the drive controller, of course, that's the computer's responsibility, but just the drive electronics, the driver circuitry for the heads and motor control and all of that. Now in this one, the drive electronics are actually on the main PCB down here, and when we lift the drive's connected. See, it's got the same cable here cable with several connectors on it. And usually these loop around and plug into the drive electronics, and then it has like a 34-pin edge connector that you connect to it, but these just all plug into the main board, and the communication with the host is through these, basically the SIO ports, the serial I/O ports with these connectors, which were proprietary to Atari and to Commodore and all of those guys. But I think at first order is to remove the drive and see if there's anything we can see right off the bat. So after removing all of the drive connectors, it wasn't fastened to the main board. It was just sitting on there, so that came out. And here's our main board. Now on the main board, this part was covered with this RFI cage, and they just bent some tabs and it came off. And this is the actual drive controller. This is the CPU. It isn't properly labeled, but I think it's like a 6507, which is a 6502 with reduced address space, so they could reduce the pin count on it. A 6810 static RAM chip. A 6532, I think that is called a Riot chip. It's the RAM I/O timer. It basically has all of the I/O pins on there, and other goodies like a timer. The EEPROM Mark Tandon, and over here is the drive controller, which is a Western Digital, and it is, drum roll, I don't know, it's printed kind of faint. You can look that up. I didn't look that up online, but that is the drive controller for this. And pretty much, you probably could, the other parts like the 6532, the 6810 can be found, the EEPROM can be found, but this reduced pin count 6502 or whatever it is, and the disk controller would probably be hard to find for replacement. But let's have a look at the board if we can see anything by just looking at it. And I can immediately see something on here, and that is this diode over here has been replaced. Where are we? If I don't cover it up, maybe. You can see how somebody just kind of put it in from the top. I don't know why they did such a shitty job, because you can get to this. This removes pretty easily, and you can get to the underneath of the board, but I guess they didn't remove the drive. They just left this sitting in the bottom half of the case. But then I looked at the underneath, and even though it doesn't show up really well on the video, you can see several places where work was done. This chip was replaced. There's a regulator over here that was replaced. There's a NPN driver. This is actually the motor driver that was replaced. And of course, over here is the diode that was replaced, and I guess they reflowed some capacitor leads over here. But let's put you on a tripod, and the trouble, when you read up on these, the trouble spot is usually the diodes over here. So a quick look at the schematics would probably clarify things a bit. So let's first look at the voltage regulator, which is usually what we should do first. And also, if you do some research, there seem to be some problems around the 12-volt regulator that have developed on a lot of these drives. But looking into this, looks pretty straightforward. At first, we got 9 volts AC coming in, going through a power switch, feeding a full-wave rectifier. The negative output becomes system ground, and the positive first goes straight into 7805, which is a 5-volt regulator, with some smoothing capacitors before and after, and that generates the system 5 volts. Now the 12 volt regulator needs about 3.5 volts excess on the input in order to properly regulate the output at 12 volts. Now remember, since we're using a 9 volt AC input, even with a good cap here, we're probably going to see somewhere in the neighborhood of 12 to 13 volts DC showing up here, disregarding these 3 components for now, if this was directly connected to here. And that isn't enough voltage, input voltage, for the 7812 to generate a clean 12 volts. So what they employ is a voltage doubler that consists of these 2 diodes and this capacitor over here. And what that does is basically the network increases the unregulated DC coming into this to enough of a level where the input voltage is high enough to allow this regulator to generate a clean 12 volts. The trouble spots in here that supposedly happen in a lot of units is the voltage doubler, the 2 diodes and the capacitor over here. So that's probably the first things we should check before doing anything else. I mean, I know, yeah, there was also a chip replaced. Well, the regulator here was also replaced, but there was a chip replaced, and but we'll get to that later on. So first, let's have a look at the capacitor that is part of the doubling circuit. If I can get a good contact here, which I can't. ESR looks good. 4723. Schematics say 4700 at 35 volts. So that seems to be in spec. Next, we'll have a look at the 2 diodes in the doubling circuit. The cathodes are down here. And the cathodes, I believe, are tied together. No, they are not. It's a cathode running to an anode. Interesting. So, well, let's measure them. We can always check on the polarity. So that looks good. That doesn't look too good. Well, we don't know because it's in circuit, so all bets are kind of off. So that doesn't really tell us anything. We need to take them out of circuit. So we took out the diodes. And let's see, this is the original 1N4001, and I was right, it's a 50 volt max forward voltage and 35 volt max reverse voltage on these. So forward is showing good, and reverse also. So this is a good diode. Now this diode, which you can see is physically looks a little bit different. Shows good and good. I mean, I looked up the number on this. It's a 1N5395. So this is a heavy duty much more heavy duty than this rectifier diode. But, and I'm not sure if mismatched diodes in there would cause or wreak havoc with it. So what I'm going to do is put 2 new diodes in there, and we'll see what happens next. So I put those diodes back in. You can see them in the center of the picture there. No, well, not back in. I put new ones in, and I mounted them kind of off board so they get a little better heat circulation. Well, then I plugged everything back in and started to test voltages, and the 12 volts was missing. Okay. Except at that point, I burnt the side of my hand because I had touched this heatsink. This very large heatsink here was hot enough to, well, burn maybe is a bit too much, but yeah, it did hurt, and this whole thing was heated up unbelievably. And of course, the only way that can happen, I mean, it's getting warm here. This is the 5-volt regulator, but it's warm, not hot. I did cool the 12-volt regulator. There's no shorts on it. And yeah, it's barely getting warm now. And then I thought, okay, let's test voltages without that regulator in there. Obviously, that guy was doing something wrong. So let's test, I mean, what we're looking at on top of the picture is the 5-volt regulator right here. And I've already found the ground point inside, which is the bottom of the diode bridge. And so here's the output of the 5 volts, 4.9, a bit low, but okay. And the input to it is 12 volts, kind of just like expected. We got 9 volts AC coming in, and with the capacitor smoothing and stuff, that makes good sense. Then I thought I'd go ahead and measure the input voltage to the 12-volt regulator, which should be roughly double this. And it's of course removed, but the input voltage should still be there. And it's a little bit more than half, but obviously the doubler is working. But then, as I was messing around with this thing, and I did some continuity checks, so I did a continuity check between ground and the 12-volt output. The output of the 12-volt regulator is shorted to ground. So that's going to be fun to find, because somewhere on the 12-volt rail, something has shorted. And that probably caused the regulator to heat up. For all intents and purposes, this guy may still be good. But it was basically because the output was shorted. Everything that was going in was getting converted to heat, and did wonders. But of course it didn't supply 12 volts, and that's why we never saw the motor running. Oh, and how did I find the offending chip? Because the whole heatsink was so hot, I mean, even lightly touching places wouldn't tell me which part. There's the 5-volt regulator, the 12-volt regulator, and a tip, what is it? A tip something. I don't have it in front of the schematics, but that's an NPN used to drive the motor, for the motor driver. So one of these was heating things up horribly, but what I did was I used my cheapo thermometer, and it's not very accurate on an absolute scale, but relatively it is. And as I went ahead and just kind of tested the tabs on each of the transistors, the temperature of the 12-volt regulator over here was almost twice as much as the others. The others were kind of high, but that's because the entire heatsink was getting very warm. But it definitely identified this one. And yeah, I took it out, and I've had it on for a while now, and the temperature is cold over here. Well, let's see what this says. It says it's 72 degrees Fahrenheit here, and it's going to be hotter here because of the 5-volt one. Barely hotter, about 73. When I measured the 12-volt regulator, when it was still in, it was reading 170 degrees. So yeah, that was something wrong, and now everything's acting just fine. So now let's go ahead and see if we can find the short between the 12-volt rail and ground. So I was able to partially isolate the short. And the way to do that is to look at the schematics and then find points where, without having to cut traces and stuff, you remove a component and it isolates a certain part of the circuit from the 12 volts. And in this case, it was this inductor over here that feeds, that is really close to the motor drive circuitry over here. This, by the way, is a tip 110 that drives the motor. And here's the 12 volts coming in, and whatever it does over here, something over here is shorted. I've already measured this transistor and it's not shorted, but let's now I did put the 9-volt regulator back in, and let's have a look, see if at least with this part disconnected, if we're going to get proper voltages up to this point. I mean, things aren't going to work yet, but at least let's see if putting a new regulator in there gets us a little bit closer. So we are on DC volts. Go to ground. Let's first make sure that our 5 is still there. Yeah, it's about 4.9, a little low, but not destructively so. And then the output of the 12 volts, if I don't short something, it's at 11.9. So now we are getting the 12 volts back, and I can touch this. It is slightly warm, but no longer nearly as hot. So now we need to look in the schematics and try to identify, since remember, whether the drive is disconnected, so the actual disk drive isn't, I mean, not necessarily that it's good, but it's not causing the short. The short is caused in this area over here. So let's get a different part of the schematics printed out and see if we can figure this out. Alright guys, I found it. I didn't show you the details because I'll spare you the swearing and just plain disgust I felt at finding it. You're looking at the problem. Let's see who spots it. So basically I traced it to the case of the tip 110, and the dead giveaway was that the screw they used has an insulator on it. So fine, it insulates the outside, but the case didn't have an insulator between the case of the transistor and the heatsink. And the heatsink's obviously grounded because the cases of both regulators are tied to it, and those carry ground. And if we look at the schematics, and even if we don't look at the exact pinout of the tip 110, that's not even necessary at this point, because looking at it we can see that no part of the tip 110 is grounded. So regardless of what the tip 110 which terminal of the tip 110 is connected to the case, we were shorting out part of it to ground. And that's why the 12-volt supply was non-existent, and the 12-volt supply was essentially trying to self-destruct. Now, before we wrap everything up, I do have some insulators and mica insulators over here to put those in. But first, let's put the drive back on and see if we can get the drive to do anything. All right. Fast forward again to the next day. I didn't get anywhere last night. But today I put back things together. I took out the tip 110 and I checked the data sheet. And it turns out that the tab is connected to the collector, which is going to the inductor. This is the 12-volt line coming in here. And that's what was causing the short, because the tab, here's 12 volts, and the tab was tied to the heatsink, which basically grounded it out. So I took it out of circuit, I tested it, but that situation probably wouldn't hurt it. And it tested good, and since I didn't have another one, I put it back in, this time properly insulating everything, and again tested the voltages. Everything was good. And drum roll please, I started everything going, and it didn't work. Same thing as before, power light would come on, but the drive wouldn't spin. So I started to poke around in the logic section a little bit to see what was going on. I got signals, but it didn't really make a whole lot of sense what I was seeing. So I went back to basics and started swapping these chips with the known good ones from the first drive that we tested. And when I reached the processor and I swapped the processor, things started to look up. Now a little bit of analysis is in order here, because here is what was in this, and it is a 6507, and here's what was in that slot. An Oki chip, focus, an Oki chip with an Atari house number on it. But it turns out that the only thing that was right about this was the number of pins on the chip. Because I did some research on this, I was a little bit suspicious, because I have never seen Oki second source a 6500 series processor. So I did a search on the Atari house number that is on this chip, and the internet told me at several hits that it was a ROM, that it was ROM number 1 for the Atari 520 ST. Believe it or not, that's what it said. So this is a ROM. Somebody had put a ROM in place of the 6507. I was going to stand here and complain about the incompetence and ineptness of somebody who forgot to insulate the transistor, but I guess that's not where it ends. Why would you just take some chip and, oh, it fits, so it must be the processor? I know, it sounds weird, but I'm not making this up. That's what happened. Unfortunately, I checked through my stuff. I don't have another 6507, but at least let's see this one. I mean, I know that the motor on signal's working now on it, which was missing, so let's kind of halfway put this one together and at least see if it works. So actually I didn't even put it together, Made sure that the drive was sitting down, not shorting against anything. And now when we turn it on, obviously the drive came on. So now let's see if we can load, if it works. Hit the option key again to go into Atari 800 compatibility mode. And it seems to be loading. So I guess we could say that the repair was a success. All I really need to do is find another 6507. And then at that point, both drives will be fixed. I've seen a lot of weird things. I've seen a lot of weird repairs. But the two problems on this one, shorting the tap to ground and then putting an entirely wrong chip into the processor board, it's a first for me. And as if that weren't enough, I did find another good one checking some video footage. Here are the connectors that come from the drive, go to the drive controller. There are 5 connectors. And you can see the first 2 and the last 2 are in line, oriented this way, but the one in the middle is actually turned 180 degrees. And that's the way it should be, because yeah, this works properly, and I observed that this is the way it was on the first drive. But when I opened this one up, this connector was turned 180 degrees, kind of made sense because it was in line with the other connectors, but it was completely wrong. So and that's the motor power connector. So if that was rotated or upside down, I don't know what else that could have caused. So here's a third one that whoever repaired this did, and it just gets better and better, doesn't it? Just thought I'd show you that too. Well, thanks for watching. I think it was a success. We got one fully working drive, cleaned it up, put it back together, and we actually do have 2 working drives because, well, let's say 1.5, because all we need is to plug in a 6507 into this socket, zip this one up again, and I already tried it. I took the 6507 out of here, plugged it in here, and tested it. So this is fully functional once the proper part is found. So finally, here's a good reason why you should definitely subscribe if you haven't already. I picked this guy up in the same haul that I picked up the drives, and he needs help. And probably next time, we'll try to give him first aid and see if we can get it to light up and write some cool basic programs. So let your thumbs do the judging, and leave me a comment about anything, especially if you have a cheap source for 6507s, and keep on trucking. But wait, there's more. Anyway, here's a postscript, or bonus footage, as some people call it. I just couldn't rest easy with the second disk drive missing a part, not knowing whether I could get that one up running. So I racked my brain and went through my stuff, and finally what I found was this Coleco Gemini 2600 clone. And yes, it has a 6507 on it, which I desoldered. So let's put this in drive number 2 and see if things are going to work for us. Alright, 6507 has been installed, and well, let's see. Well, that's a very good sign. It retracted the head, which means that 6507 is running. So and it's loading. Looks like we did get both drives fixed. Well, actually the first one was already working, but after all the switching of parts and stuff like that, it's good to know that we now have two drives that are working, which we will find out in a second. And we're almost there. Will it work? Yep, it does. So, yes, we are finally done. See ya.